All right, let's get into it. Today, we are cracking open a case file on one of the biggest mysteries happening inside our own bodies. We have this absolutely incredible defense system, right? A microscopic army that protects us from countless threats. But what happens when that army, well, when it goes rogue? When it overreacts to something totally harmless? That's what we're going to investigate. The fascinating and sometimes frustrating world of hypersensitivity. And this right here is the million-dollar question. Why does a system designed specifically to protect us sometimes cause all the misery of allergies or even way more serious conditions? It's a total paradox, isn't it? It seems like the better our defenses get, the more potential there is for them to just completely go haywire. So the official term for all this is hypersensitivity. But here's the twist. It's not always a mistake. See, sometimes, like in a tuberculosis infection, the immune system's powerful reaction is actually what's needed to wall off the bacteria, even if it means causing some collateral damage to our own tissues in the process. So you can see it's a whole spectrum, from a simple, harmless overreaction to a necessary but pretty destructive defense. Okay, let's open our first case file, the classic allergy. The best way to think about this one is like your body's security system has a really, really faulty sensor. This is what we call a type 1 hypersensitivity reaction, and it is by far the most common one any of us will ever experience. A type 1 reaction is always a two-act play. The very first time you encounter something like ragweed pollen, nothing happens. You don't even notice. But behind the scenes, your immune system is in what's called sensitization mode. It's busy producing these special antibodies called IgE, and it's sticking them all over certain immune cells. Then, the next time you breathe in that same pollen, Act 2 begins. The pollen acts like a trigger, linking two of those IgE antibodies together. And bam, the alarm goes off. So who are these cells that are just covered in these IgE tripwires? Well, meet the sentinels of your immune system. You've got mast cells, which are like the stationary guards. They're posted in tissues that face the outside world. Your skin, your lungs, your gut, they are the absolute first responders. Then you have basophils. Think of them as the mobile reinforcements, just circulating in your blood, waiting to be called into the action. And when that alarm gets tripped, what actually happens? Well, the mast cells and basophils degranulate, which is just a fancy way of saying they unleash their weapons. And the main weapon in their arsenal is histamine. The best way to think of it is as a pre-packaged chemical grenade. It's already made, it's stored, and it's ready to be launched in an instant. That's why these reactions are often called immediate hypersensitivity. So how can this one little chemical cause so much chaos? Well, histamine widens your blood vessels, which is why your skin gets red. It makes those same vessels leaky, which causes swelling. It contracts the smooth muscles in your lungs, and that leads to wheezing. And it kicks your glands into overdrive, which is what gives you that runny nose and watery eyes. Yep, every single classic allergy symptom can be traced right back to these effects. Now, in its most extreme form, this exact same process leads to something called systemic anaphylaxis. This is what happens when the reaction isn't just in your nose or on your skin, but it happens all over your body, all at once. Widespread bronchoconstriction makes it incredibly hard to breathe, and a massive sudden drop in blood pressure can lead to shock. It's a truly terrifying demonstration of the immune system's raw power. All right, let's move on to our second case file. If type 1 was a faulty alarm, then type 2 is all about mistaken identity. In this case, the immune system makes a totally different kind of mistake. It starts creating antibodies that target antigens on the surface of our own cells. What's so fascinating about type 2 is that it can cause damage in three totally different ways. The antibodies can tag a cell for outright destruction, or they can trigger localized inflammation that causes a bunch of collateral damage. Or, and this is the most subtle one, they don't kill the cell at all, they just hijack its controls. And this slide just perfectly illustrates that hijacking process. So in Graves' disease, you have antibodies that act like a key stuck in the ignition of your thyroid. They're constantly pressing the gas, telling it to make more and more hormone. But in myasthenia gravis, the antibodies do the exact opposite. They basically put a boot on the brake pedal of your muscle cells, blocking the signal to contract and causing weakness. In both of these cases, no cells are actually being killed, but their function is just completely out of whack. Okay, our third and final case file involves a different kind of problem altogether. With type 3 hypersensitivity, the issue isn't antibodies attacking cells directly. No, it's about what happens when antibodies bind to antigens that are just free floating in our blood, and they form these tiny little clumps called immune complexes. You can think of them as a kind of sludge that can, clog up the whole system. The classic example of this is something called serum sickness. So imagine a patient gets a life-saving antivenom that's made from horse proteins. Initially, it works great, but over the next week or two, their body starts making antibodies against those foreign horse proteins, forming a huge amount of these immune complexes. This molecular sludge gets stuck in tiny blood vessels, especially in the kidneys, joints, and skin. And that triggers a massive but delayed inflammatory response. So, we've investigated the crimes. Now, how do we actually solve them? Let's take a look at how we can diagnose and manage these immune overreactions. But first, let's just take a second to appreciate the scale of this problem. A staggering 40%, 40, of people in the US have experienced an allergic disorder. This is not some rare thing, it is a major public health issue. So, how do you find the culprit? Well, it often starts with a really simple skin test. A doctor introduces just a tiny amount of a suspected allergen into your skin, and they watch to see if your local mast cells release that histamine. If they do, you get that classic telltale itchy bump, what they call the wheal and flare, and that confirms the allergy.
But what about actually treating the problem? Well, that's where desensitization comes in. It's basically about retraining the immune system. You can think of it in two ways. There's a short-term fix if you need to take a drug you're allergic to, and then there's the long-term project, like allergy shots. The whole goal of allergy shots is to coax your body into making protective IgG antibodies. These IgG antibodies act like bodyguards, intercepting the allergen before it ever gets a chance to trip the alarm on your mast cells.
And all of this leads to a really fascinating big picture question. Why are allergies on the rise, especially in developed countries? One of the leading theories is called the hygiene hypothesis. You see, our IgE antibody system originally evolved to fight off things like parasitic worms. This quote sums it up perfectly. In our super clean modern environments, we just don't have parasites to fight anymore. But the IgE system, it's still there, it's still ready for action. So instead of fighting worms, it starts targeting harmless things like pollen or peanuts. Which leaves us with a pretty provocative thought to end on. By cleaning up our world so effectively and by eliminating these ancient enemies like parasites, have we inadvertently left our powerful immune systems with nothing to do? Have we actually made them bored? It's a compelling question, and it really makes you think about the unintended consequences of our own success.